So we saw before that if you have two sentences and you want to connect them, you use a connective. And that creates something called a compound sentence. So let's look at another connective. We already saw and. Now we're going to see something called or. Suppose sentence 1 is, he earned an A in his science class. And sentence 2 is, he earned an A in his history class. The connective is or, and the compound sentence would be, he earned an A in his science class, or he earned an A in his history class. The notation we're going to use is P would represent he earned an A in his science class. That would be the first sentence. Q would be he earned an A in his history class. That's the second sentence. And then we're going to use this symbol right here. So if you remember when we did and, we had something that looked like an A without this middle part. So it was this symbol right here. That kind of reminds you of and. And I guess now we have or. I don't know, that doesn't really make sense. But if you can just remember that this one is for and that this symbol right here is for or, then you shouldn't get mixed up. So this is going to be or. So this would be P or Q. He earned an A in his science class, or he earned an A in his history class. Two simple sentences that are joined with the word or form a compound sentence called a disjunction. So if you remember, and formed a conjunction, or forms a disjunction. So let's determine the truth value for the disjunction. So let's say we have our sentence, our compound sentence here. He earned an A in his science class, or he earned an A in his history class. And let's look at all the possibilities with a tree diagram. So we have P is true or P is false. So let's first look at P is true. And we could have both things being true. He earned an A in his science class and he earned an A in his history class. And I should be careful not to use the word and or incorrectly here, but we're going to assume that both of these individual sentences are true. So would you say that he earned an A in his science class or he earned an A in his history class overall is true? And I would say, yeah, that makes sense. That would be true. How about if Q is false? So that would mean that he earned an A in his science class is true and he earned an A in his history class is false. So what would we say about he earned an A in his science class or he earned an A in his history class? Well, the or meaning here, we would say that's still true because we said or. How about if P is false and we have Q being true? So he earned an A in his science class is false. He earned an A in his history class is true. And for the same reason that we saw for the previous one, this would also be true for P or Q. Now, everything has been true so far, but what if they're both false? So he earned an A in his history class is false, and he earned an A in his history class is false. Those are both false. So what about P or Q? Well, now it's false. Since both of these things are false, if you have something false or something false, overall the whole thing is false. So we see that P or Q is true whenever P is true, Q is true, or both P and Q are true. Now, we have one extra thing to talk about with disjunctions that didn't happen with conjunctions. Consider this sentence here. So first, let me put what we saw before, the rule for determining the truth value. And consider this sentence. Either she lives in New York or she lives in Florida. Okay, so if we were going to use our notation from before, we could say that the either she lives in New York part, that could be P. And then we have an or right here, so that's or. And she lives in Florida would be Q. Either she lives in New York or she lives in Florida. Well, here's the problem. The rule we said up here is that P or Q is true whenever P is true, Q is true, or both P and Q are true. But think about it. If this is true, she lives in New York, and this is true, she lives in Florida, then this entire sentence, either she lives in New York or she lives in Florida, would be false. I mean, she can't live in both places at the same time. So something doesn't make sense here. And it turns out there's just two different ways to define or. So we have something called an inclusive or. That's where P or Q or both are considered. And an exclusive or, either P or Q, but not both of them. So the inclusive or was what we were using before. This inclusive or goes by this rule right here. But this exclusive or, that would be something more appropriate for a sentence like that, where we have either P or Q, but not both of them. In other words, when they're both true, then the exclusive or, P or Q, would be false. But in mathematics, we can't tolerate ambiguity. We got to pick something and stick with it. So in this course, geometry, and in mathematical logic in general, unless we say otherwise, we are always going to use the inclusive or.